All right, so let's talk our strategies for solving one of these integrals that has two variables. Integral over some region R, f of x, y, integrated with respect to two variables. And really what this is going to look like is it's going to look like, oops, these are kind of unnecessarily far apart. It's going to always have constants on the outside and functions on the inside. And it can be written as something dy dx, meaning integrate with respect to y and then x, or dx dy, meaning x and then y. These are equivalent. And what you always have is that the thing inside can be a function, but the thing outside always has to be a number. Just like when you evaluated your integrals, you always put numbers on your outside integral. It just happened to be the only one. And so we're always going to solve for these. In two pieces. We'll treat the outside variable as constant. Integrate the inside variable until it's gone. Then integrate the outside variable until it's gone as well. And you'll only have a number left. Whenever you had one of these definite integrals, it always ended in a number. Your x's disappeared. Same thing will happen here. And when I say outside inside variables, I'm talking about your inside variable is y, outside variable is x for that first one, or for the second, x was inside, y was outside. And so let's just look at the first one. What I'm saying is ignore that you have two integrals. Just take your first integral, ignoring the outside part, and you know how to do this. And then that's going to become something that's kind of a new function with respect to x only. And then you can do that like Calc 1 as well, where the new function with respect to x is just the first integral you had right here. Maybe I should have written this example with dx dy. That might be more intuitive for you all, but you're going to have to get just as comfortable doing it dy dx, so we'll go ahead and keep it this way. And I know this is going to feel really like abstract until we start doing problems. I just really want to build a strong foundation, so stick with me through the end of this video, and then we'll start actually plugging in functions and numbers, and it'll feel more real. I just want to give you some warnings because these problems can be really tricky. So first of all, less of a warning and more of just a statement. These bounds, ax, bx, or ay, by, can be constant. That's actually the easiest type of double integral you'll take. Maybe it just says like 0 to 1, 0 to 1. You don't have to worry about much. The hardest part of these problems is defining your region R and finding the bounds A, B, C, and D. So this A of X, B of X, C to D, or A of Y, B of Y, C to D is describing this shadow I talked about in terms of functions. And that gets to be really difficult once you start being given more complicated functions. And so I just want to sketch some pictures of kind of what you'll look for. Okay, so the type that's going to be more intuitive, I did it backwards the first time. I think this is going to be slightly more intuitive to look at a picture. So we'll do this one first again. So here's your XY plane. And here is your region R. So it's just a random shape. This is like the hand I showed you before. Now it's this wonky, curly rectangle thing. And your A of X and B of X tell you the heights when you're integrating with respect to Y. So the lowest thing is A of X. The highest thing is B of X. And then your constants C and D tell you the lengths when you integrate with respect to X. The thing that's furthest left is your C, and the thing that's furthest right is your D. And those ones at least should feel kind of familiar to you because you're used to when you integrate with respect to X having constant numbers for your interval, just like you had over here for your integral from A to B. The other way this will look for you is the f of xy, where you integrate with respect to x first and then with respect to y. So here's our xy plane again, and now we're going to do like that. Here's our region R, where the top part is kind of flat, the bottom part is kind of flat. And so your A of y and your B of y are these curves right here. The thing that's furthest left is still your A, your lower bound for x. The thing that's further right is your upper bound for y. And so when you go from left to right lengthwise, you find your bounds of integration for x. But now they're bendy, they're not constant numbers. And then going from bottom to top, up and down, gives you your C and D. Lower bound for y is the lowest on the picture. Upper bound for y is the highest part of the picture. And now those C and D are constant numbers along the y-axis instead.